Here's a simple example, okay? Line fitting. And you might wonder, why might I want to find lines? Well, as the example shows here on the left, you might want to know that your chips are seated correctly, so you see the lines on the chips. Or this is the tower, again, from University of Texas, and you find the edges, and you might just want to see whether or not you might be in the state legislature, and you want to make sure the tower at the University of Texas is not leaning to the left. That's a joke for some of you. But we're going to assume for now that finding lines is something we want to do. So you might be wondering, well, wait a minute. We just spent a long time learning about how to find edges. Aren't we done? Can't we just find the edges? Well, if that were true, I wouldn't be standing here. So let's talk about the difficulty of line finding. So here's that same University of Texas tower, again, courtesy of Kristen Grumman, and we've run an edge operator. And what I've done here is I've pulled up a part of it just so we can talk about some of the phenomena. So problem number one is that there's lots of points here that have nothing to do with the lines. Okay? So all these little edge points down here, these have nothing to do with the lines, so we have to be able to deal with them efficiently and rapidly. Second, only parts of the lines are actually detected. So for example, here you can see that there's this big gap in the line, even though what we'd really like to do is say that we found the entire line. And finally, there's noise and corruption actually where we do find the edge. So over here, you'll notice that in these lines across here, there's all this stuff that doesn't exactly lie on the line. You can see the pixels are jumping around here as well. So we have to be able to go from these noisy measurements of where the edges are in order to find the actual lines.